Cappuccino assassino, everybody. Gosh. My kid gets in trouble if he says that at home, just for the record. That's Italian brain rot stuff, right? Because it's super annoying is the only reason why. Like, he'll tell me, like, don't say a bad word, Dad, if I say, like, butt or something. Like, he gets on it, and then he'll say just terrible, terrible brain rot stuff. Anyway, we are continuing. We are in 2.2 still, where we were talking about the standard form of a quadratic. Today, we are going to look at a last example together, where we want to find the quadratic. Find the quadratic through, and we get 3 points this time. We're going to talk about why this is different. I want the quadratic equation that's through the point 2, negative 3, 3, negative 6, and negative 1, negative 6. Okay. This is where we're starting, and I almost made the bell ringer just kind of a warm-up to get this problem set up, but I think that going over the graphing part is just as good. All right, first thing that I care about, we've done equations, and we've done work where we found the equation of a quadratic. How is this problem different? I'm going to give you like 30 seconds. We'll go 60 seconds because I have a 60-second timer. Chat with your neighbors, look back at the old problems where we were finding the equation of a quadratic, and tell me what's different about this problem compared to the ones that we were doing before. So specifically, if we go back to 2.1, let's find where we are. Look at 2.1. What's the problem we found? So let's see here. We want to find the equation. So here's one where we did it, where they gave us the information. Yep, and slice is fun because so here's an example. There's an example in 2.1 where we did this before. 2.1, I'm sorry. There's an example from 2.1 where we've already done this, but this problem's different. When we did these problems before, we were given the vertex and a point. Now, that is really helpful because we have a form of a quadratic that has a vertex in it. Did I ever tell you the vertex here? Okay, so very different problem. Now, maybe I gave you the vertex and we'll find out, but I don't think I have. How on earth are we going to find the quadratic that goes through these 3 points then? Do we have a general form of a quadratic that we can deal with? Or a standard form, maybe? What is the standard form of a quadratic? Y equals something. Ax squared. If I know that this is the general or the standard form of a quadratic, if we knew A and B and C, would we have everything we need? Do we have A or B or C? Not yet. I don't think we have A or B either. Not yet. We also don't have C yet. But gosh. Well, notice, this general form, does it have an X and a Y? Now, in fact, there's two X's, but they're both X, right? One of them just got squared. And each of these points, they give us an X and a Y. I'm going to do the first one, like we'll do the first one together as a whole class, and then we'll kind of decide where we're at, and we get a little bit of review of some stuff that we've already seen, which hopefully is nice. All right, using this equation and each X and Y, I'm going to go ahead and color code these. I'll say X and Y for my first one, and I'll change color each time. Can we write this expression plugging in this X and this Y? So for this Y, I'm going to put in a what? So negative 3 is equal to A times, what are we going to plug in for X here? And what happens with that X value? Squared plus B times, what am I going to plug in for this X? It's another 2 because that's the order pair I'm plugging in, plus C. All I've done is I've looked at this and said, okay, you gave me an X and a Y, let's plug it in. I'm going to clean this up just a little bit, and I want your guys' help with it. This is going to lead us, and we'll have a system of equations here in just a moment, but this is negative 3 is equal to how many A? Somebody said it. I think it was King. 4? I heard, was it you? Nice. Plus, how many B terms? 2B plus C. We now have a single equation that we can solve. Okay, the good news is that we also have a couple additional points. We have this X and this Y. And I'm trying to find a different color. We have this x and this y. What I want you guys to do is very similar to how we did this first one, plugging in the x and the y. I want you to plug in x and the y here and here and get me 2 more equations. We'll meet up in just a moment. If you are looking at this and going, I still don't know what to do, is that okay?
Yeah.
Yes, as long as you let me know. Holloway, I have no idea what's going on. Can you please help? I will give you guys a minute or 2, and we'll come back together before we solve the big system. We now have a system of how many equations? 3. And how many variables? 3. That's okay. We have to solve for one of them. Now, Sebastian asked, do we have to eliminate? We could. Do you guys lean toward elimination or substitution? I used substitution when I did it. Is that the only way to do it? If you wanted to use elimination, and Seabass, I would encourage, if you would like to, you should. What would you eliminate? Because, go ahead, sorry.
Oh, I don't know. It's just lined up perfectly. If like we just like solve it and then down.
So we are going to solve it. If we wanted to eliminate, you could eliminate anything that you wanted, but I would use this bottom equation and I would eliminate the b's if I was going to go that way.
Oh.
That's how I would do it. But I'll tell you, if we have something easy to solve, let's try to knock that out. I'm going to make a suggestion here. I want us to solve this bottom one, and you might do it differently, but if we all do it the exact same, then we'll be able to find the mistakes if people are making just mathy mistakes. For this, let's solve this one for, I don't know, A. If you wanted to solve this equation for A, what would you have to add to both sides?
Plus b minus c.
So plus a b, minus a c, and minus 6. I just took this, plus b, and minus c, and I'm going to put a star next to this. Not because I'm done, but because I don't want to lose it. Yes, miss?
Why are there no numbers?
Because if we plug in here, do you agree it's negative 6 equals a times negative 1 for the x, plus a b times negative 1? And if we squared negative 1, what's negative 1 squared? Good. If you want to write a 1 and a 1 here, you can, but we don't typically do that. Yep, just because they're 1 is the only reason. All right. With this lovely expression, I now have a way to get rid of any a term. Do these other ones have a terms in them?
Yes.
Can we plug this value in for this a and this a?
Yes.
Okay, I'm going to hook you guys up. You all do the blue one, I'll do the yellow one. We're going to come together with a system of 2 equations here in just a moment. You are going to, I like it. You're going to substitute a into the blue one. I will do the yellow or orange one. Cool. Take this a and plug it in right here, and then clean up that equation. I will do the same thing with the orange one. When you have the blue one solved, check with your neighbor. I'm going to put a star next to the orange one. We're just splitting the labor here is all.
Why don't you simplify it further more?
I will. Here in a minute. I will. 100%. Love that thought, Sebastian.
Yeah, minus 24 until outside was
So notice that you no longer have a, right?
It would be positive 24 on this side and minus 24
Wait,
what? No, because you're moving it to the other side.
Okay, so I am nearing the end of mine here. Can you guys confirm or refute that this is what we get? Negative 3 is equal to 6b minus 3c minus 24. I'm going to do one more step. What am I going to add to both sides?
24.
So I get positive 21 is equal to 6b minus 3c.
Yep.
I'm going to put a star next to this. Now, this problem's big. Did I lose you somewhere, Kennedy?
That's
Are you okay with getting how we solve this one for a? Okay, and then all I've done is in this expression, anywhere that there's an a, I just plugged it in, right? So there I am, and then I've distributed, and then it's just a matter of doing the math. So I distributed here, and then I have these terms, I don't lose them, and then I'm just combining any and all like terms, then I add 24 to each side. Okay. Now, notice, we have two equations on the board now, at the very bottom, and they both have how many variables? 2. Are they both the same variables?
Yes.
Excuse me. Goodness. So, can we solve a system of two equations in two variables? Question. Okay, so checking it out. I'm going to check and let you guys do this. I want you to solve this system. There is not a right or a wrong way. You can use elimination or substitution. Talk with your neighbors. Talk with me if you need help. I'm just rewriting the same system with just the two equations that we found. The goal here is that when we solve this, whether it's for B or for C, we're going to get a number. Once we have a number for it, it is super duper easy to solve, and we'll backtrack through the problem to get our end answer. Looking at this, elimination or substitution, I don't care which one you go with. What would you go with? Fair? For what? Okay. Whether it's elimination or substitution is your call. If you have no idea what I'm asking you to do, please, please, please don't sit there in silence. I'll be walking around. I can help. I will help. Now, decision time. Are we substituting or eliminating?
Eliminating.
Okay. I think that most people substituted. I don't know if that's true. There's not a right or a wrong way, right? Okay. If we use substitution, so we have to solve this system. If I use substitution, I think this one's easy to solve for C. Okay, I'm going to solve this equation for C. I'm going to add 3C to both sides, and I'm going to subtract 21 in the same step. Okay, just to try to clean up the work a little bit. Add 3C, subtract 21. Could I now solve this for C?
Can you simplify before you solve?
You could, but I'm going to simplify now, so it's the same difference. What would I do to solve for C?
Divide by
Indeed, it is divided by 3, and I think I get 2b minus 7. Everybody agree with that?
Yeah.
Now, here's the cool thing. This equation has a c in it. If we know what c is and we plug it in, I think we're going to be able to solve. So I'll take this value of c that we just found, and I'm going to plug it back into the other equation. 48 is equal to 12b minus 8 times c we already decided was 2b minus 7. I now have a single equation written with a single variable. We can get a number out of it, and then the rest of the problem just comes tumbling down behind us. So let's just see what shakes out. We get 48 equals 12b minus what?
16b, negative 16b.
Minus 16b
Positive 56.
plus 56. I'm going to subtract a 56 from both sides, and I get a negative, what, 8? Equals negative 4b. Did I make a mistake? What do we get for b?
2.
I think that b is 2. Now, the good news is that if we're wrong, you think we'll find out? Yeah, because anytime we're solving a system, we can check it. I'm going to put a star next to this number. Well, if I knew b, could I get a c? Right here. Okay, well, let's do that. C is equal to 2 times, what was b again?
2.
2 minus 7. What's 4 minus 7?
Negative 3.
Negative 3. I now have 2 of my 3 values. How on earth can I get the third one? Because the only thing left is a. Hey, check out this original statement. A is equal to b minus c minus 6. Okay, well, if a is equal to b minus c minus 6, what was b? 2 minus a negative 3 changes to plus 3 minus 6. What's a? Negative 1. This is a big problem, right? Like not, let me rephrase that. This is a large problem. Like there's a lot of stuff in here. Okay, going through. If I've spent the last 15 minutes trying to solve a problem, I'd sure like to know that I'm right. How do we verify that we're right? Plug it in. We have 3 equations that we started with that should all be true. I'm going to zoom out just a little bit so I can see both of them, or all of them rather. And let's check. So here are my 3 equations. I'm just going to plug in and check. If I do -4, that's 4 times -1, bless you, plus 8 is positive 4, minus, let's see, 4 times, so -4, plus 4 is 0, minus 3. Yep, I got -3. Do you think it's going to be true in the other 2? Should you check it? Am I going to check it right now? In the interest of time, I don't think so. I'm convinced with these. We've gone through all of this work. What's the very last thing we should have? Yeah, let's write the quadratic function. It is y is equal to, we already know it's ax squared. What's a? -1 x squared. Plus bx, which is 2x in this situation. And then finally, minus 3. We have the quadratic equation through these points. Awesome. Okay, these problems, yes, miss? Once we got B? Okay, so we'll come back through. Let me zoom in real quick. Okay, when we got B, Kennedy, are you okay with getting B? Also, thank you for speaking up. That's super helpful for me, by the way. If we get a value of B, notice that was when we solved this system, right? So once we have B, or C, whatever the case is, we got B. I'm going to plug it into the other equation, which is just this other equation. Let me see. Yep, so we got C equals this, and then I plug it in for this C. I use the bottom equation to solve for C, and then I'll plug it into the top equation. So notice we got this one for C equals this mess, right? And then I notice that the other equation has a C in it. So I just plug it in, and we get a value for B. And then once I'm there, if you have this written, if I know the value of B, I can get C, right? So once we found B was equal to 2, I just look back at this original one that we solved for there, and I plugged in 2 for B. I take this B equals 2, and I plug it back into whatever this one was. I then get my value for C, and then I'll go all the way back up to the top where I had that equation with A. I'll come look at yours specifically. I'll help you sort it out. Okay, for the rest of class, how much do you guys have with your calculators? Like, how much experience do you have with the TI-84s? Do you guys ever remember doing linear regressions, asking your equation to find a line? Okay, so I'm kind of torn here. Here's where I don't necessarily know that there's value in it. Am I gonna, is this a calculator class? Like, am I just teaching you how to use calculators? Are we all aware that calculators can do a lot of the stuff that we're doing here? Yeah, but again, I don't really care about the calculators. Here's what we're gonna do. I'm gonna not show us the calculator stuff right now because I don't know that there's a ton of value at this point in time of seeing how to do it on the calculator. Okay, with a problem this long, do you anticipate that your test will have a bunch of them? Really? No. Probably not, right? Like if it takes 20 minutes to do one problem, that's not a great problem. For that, what I want you guys to do is come up here, and we've had a little bit of time. We're through 2 sections. I want you to come grab one of these, knock down the summaries at the end of each section, 1 and 2. Don't lose this. I'm giving you a little heads up to start your note card early. Start your note card, don't lose it. There's not a quiz tomorrow or nothing, but this will be beneficial to us in the end. Come grab your note card at the end of sections 1 and 2. Every section in your book, there's a summary where they say, hey, here's the main ideas that got covered. I want you to knock them out on your note card right now. Just to be super duper clear, because I've still got some blank faces. Here is 2.2. We just finished it, right? And whether you're aware of it or not, we did just finish it. If I look in my text, or your neighbor's text, if you don't have a book, at the end of 2.1, This stuff is pretty complex. Check it out. At the end of each section, here's the summary that we saw. They are identifying all the key features of our graph, the vertex, the axis, the symmetry, and the y-intercept. This would be good stuff to have on your note card when the test comes. Take the time now to get the stuff on your note card, purely the content from section 1 and section 2, and I'll come around. We have no additional homework tonight. Get started on this. There's a little summary on page 73. The other summary, just to check, at the end of lesson 1. Here's the summary at the end of section 1. Page 73 and 65, the main concept. If we start on our note card now, it'll be a heck of a lot less labor included for when we actually use it. Cool. Come grab a note card.